Hey guys, welcome to another A-level maths improvement video. In this video today we're going to take a look at some mechanics, and the topic we're looking at is vectors in mechanics. So this is introduced as first year material. Hopefully it shouldn't be found as a tricky topic. So let's take a look at some of the questions we've got today. So these questions are taken from old exam papers. So this first question here is taken from the January 2012 paper. So let's get the right pen colour. So question 3 here. We've got three forces, F1, F2 and F3, that are acting on a particle P. So we're told P and Q are constants, and we're also told that the particle P is in equilibrium. So the first part wants us to just find the value of P and the value of Q. So how do we do this? Well, we're using the fact that the particle is in equilibrium. Because if the particle is in equilibrium, what that means is that the resultant, the sum of the three forces, the I component and the J components will both be equal to 0. So in that case, all I need to do is add up the I components and then equate that to 0. Repeat that with the J component and again equate that to 0. And then just solve for P and solve for Q. So if we do that, so if we work out P first, that's going to be 7I, so 7, plus 5I, so plus 5, plus the P. Remember, the sum of these will be equal to 0 if it's in equilibrium. Okay? So 7 plus 5 plus P is equal to 0. So in that case, that's 12 plus P is equal to 0. So in that case, solving this would just give us P is equal to minus 12 there. Okay, so that's the value of P. And we just repeat this now for the J component to work out Q. So minus 9 plus 6 plus Q. Again, this is equal to 0 because this is in equilibrium. So in that case, this would be minus 3 here. So minus 3 plus Q is equal to 0. So in that case, Q is just simply 3. Okay, so the value of P is minus 12 and the value of Q is 3 there. Now for part B, that was part A. For part B, we're told that the force F3 is now removed, and then the resultant of F1 and F2 is R. So we're asked to work out the magnitude of R. So to work out the magnitude of R, first we obviously need R. So let's just work out R first. So again, the resultant, so we're just adding F1 and F2 together. So that's going to be 7 plus 5 for the I component. So we get R is 12I. And what would my J component be? That's going to be minus 9J plus 6J. So in that case, we get minus 3J. Okay. So to work out the magnitude then, all we do is we square both of these, add them together, and then take the square root. So the magnitude of R, we just do the square root of 12 squared plus this squared here, so plus minus 3 squared. Okay, if we work this out, this is 144 plus 9. 144 plus 9 all the one square root, which would give us the square root of 153 there. Okay, you can give it as a decimal if you want, but I'm just going to keep it as a square root of 153. Okay, so that's part B done. And then finally for part C, let's just clear all this first. We're asked to find the angle to the nearest degree that the direction of R makes with J. So let's just do a bit of a sketch here to make this easy to see. So it's a bit tricky for me because I'm doing it by freehand, but if you use a ruler, it'll look a lot nicer. So this would be my I component here. This would be for J. So we want to do the direction of R first. So remember R was 12I minus 3J. Okay, so 12I, that might be saved there. That would be my 12. So that full length there is 12. And then we are minus 3J, so that's 3 down here. So let's just say that's there. So my actual direction of R would be simply this here. Okay. So that would be R. Now the actual angle we want is the direction of R that it makes with the J component here. So that's simply this full angle here. Okay, so we just do a little bit of a sketch. our shade. We want this angle here. Okay. So how do we work that out? Well, hopefully it's clear to see that the angle between the I and the j component here is 90 degrees. So all we need to actually do now is work out this angle here. So if we work out this angle here, we call that theta. If we can work out theta and then add that to 90 degrees, we've then calculated that angle. So if I just do a little bit of a sketch here, it's a little bit off, but let's just say that's that point there. So this is 3 going down, this is 12 across. So to find theta, well, this is just simple trigonometry. This will be tan theta. Tan theta is equal to 3 over 12. Okay. So in that case, to work out theta, we just do tan inverse of both sides. So it'd be tan inverse of 1 over 4, which would give us 14.03 degrees. Okay, working in degrees, so 14.03 degrees. So therefore, in that case, the angle we need is simply 90 degrees plus my 14.03. And if we add them together to the nearest degree, that would be 104 degrees. To the nearest. Okay, so obviously that wouldn't be quite what it is, but to the nearest, we get 104 degrees there. So I hope that one's helped. Let's take a look at the next question then. So the next question, again, using vectors throughout the question. So the first part, we're asked to show that the magnitude of the acceleration of p is 2 root 13 meters per second. So to do this, question 5a, we're going to use Newton's second law here. So we're going to use F equals ma. So how do we know we're using F equals ma? Well, whenever you've seen the fact that we're looking for acceleration, F equals ma can always play a part. And because we've also got the mass of the particle p, it's looking very likely that that's what we're going to need to use. Okay, so I want the acceleration first. Okay, so we've got the particle p, it's got a mass of 0.5 kilograms, and it's moving under the action of a single force. Okay, so we've got the force, we've got the mass, so in that case, the acceleration a would simply just be the force divided by the mass. So in that case, a is just simply going to be 3 minus 2, because that's our force, 3I minus 2j. I'm going to divide that by the mass of a half. Okay, so 0.5. So in this case, all I'm doing is timesing both of these by 2, because I'm dividing by half. So 3 divided by half, that's the same as timesing 3 by 2. So we get 6 there, and then minus 2 divided by half, we get minus 4. Okay, so my acceleration is 6 minus 4. But remember, we want the magnitude of the acceleration. So in that case, we square both of these, add them together, and then take the square root. So that's simply going to be 6 squared plus minus 4 all squared. Okay, if we work this out, this would be the square root of 36 plus the square root of, so it's going to be the square root of 36 plus 16. Apologies about that. And then if we add them together, that would give us the square root of 52. Now don't forget, we want to show that it's 2 root 13. So this here, this we can split it up, because it would be the root 4, square root of 4 times the square root of 13. And this simply becomes 2. So we get 2 root 13. And because we're working with acceleration then, make sure you get the correct units. Okay, as required there. So that's our first part done. Part B then, we want to find the velocity of p at time t equals 2 seconds. So again, let's just clear this. We don't have a lot of room for these questions, but as long as you can follow, that's the most important thing. So for part B then, we know at time t equals 0, the velocity of p is I plus 3j. So the fact that we're given the velocity when t is equal 0, so our initial velocity, which would be u, if we're using SUVAT equations. The fact that we're given that suggests to me that we're going to use SUVAT equations. So we want to work out the velocity. We're given a time, t equals 2 seconds. We've worked out the acceleration as well in part A. So the fact that we've got the acceleration, we've got the time, and we've got the initial velocity given to us, that suggests to me that we're going to use v equals u plus at. So in that case, v, that's what we're going to work out now, is equal to u. So that's the initial velocity, which they've given to us. That's 1 plus, well, it's I plus 3j, so 1, 3. And then we do at. So t is 2, so that's 2 times a, which a we've just worked out in part A. So what's that going to be? Well, that's going to be 6 minus 4 there. So if we work this out, so it's going to be 1 plus 12, so that'll give us 13. And then 3 minus 8, so that'll give us minus 5. Okay, so that's our velocity there. But if we write it as with I and j components, that would be 13i minus 5j. So that's part B. Part C then, let's have a go at this one. We're told that another particle q moves with constant velocity, v equals 2i minus j. So we want to find the distance moved by q in 2 seconds. So, to find the distance then, all we simply need to do is work out the magnitude of the velocity times by the respective time, which in this case will be 2. So we've got the velocity, so it's going to be 2 minus 1, 2i minus j. Then we times it by the time, which is 2. What will that give us? That's going to give us 2 times 2, which is 4, minus 1 times 2 is minus 2. And then what do we do? Well, to work out d, we take the magnitude of this. So, oops, sorry, just scribble that out. So the magnitude of d here, or the magnitude of this here, will give us the distance. So I take the magnitude of this, that's going to be 4 squared plus minus 2 squared. That's going to give us a square root of 16 plus 4. So that's root 20. And if we simplify root 20, we could write that as root 4, root 5. And then again, this would be 2 root 5. What units are we working in? So meters. So 2 root 5 meters there. Okay, so that's part C for the 2 marks there. And then for the very last one, part D, so quite a lot of marks this question overall. We want to show that at time t equals 3.5 seconds, both of the particles are moving in the same direction. So in this case, if they're moving in the same direction, what that means is that there'll be a multiple of each other. So let's just say we work out the velocity of p first. Velocity of p. So I'm going to call that vel p. Oops, where's my pen gone? So this is going to be equal then, again, using my SUVAT equation, so it'd be equal to my initial, so that's going to be 1, 3, plus AT, but obviously don't forget in this case, t is 3.5, so it's going to be plus 3.5 times A, so A is still from the one we worked out in part A of the question, so that's 6 minus 4. So if you plug this into your calculator, what you're going to get here is 22i and minus 11 here, so that's minus 11j. That's 22i minus 11j. But if you notice, we know the particle q has constant velocity, 2i minus j. Well, I can actually factor out here. This is 11 lots of 2i minus j. And this, in other words, is just 11q, okay? Because it's 11 lots of the velocity of q, so 11 velocity of q. Because that's 2i minus j. So because it's a multiple, so the velocity of p is just a multiple of the velocity of q, in that case, they must be moving in the same direction. So therefore, moving in the same direction. So hopefully that was clear. So that brings us to the end of that question, quite a long one, but job done. And then we move on to the very last question then. We've got this question here, bit of a shorter one. So, January 2007, this question. Question 3. So we've got a particle P of mass 2 kilograms. It's moving on the action of a constant force F newtons. So we've got when t is equals 0, we've got the velocity is 3I plus 2j. So again, we've got an initial velocity. We're told that when the time is 4 seconds, it's got this given velocity here. So the first part wants us to work out the acceleration of p in terms of I and j. So again, due to the fact that we've got initial, we've got a time, I'm going to use v equals, so using v equals u plus at. So in that case, what's this going to be? Well, we know v in this case is our final velocity here, which is 15I minus 4j. So that's 15 minus 4. This is going to be equal now to my initial velocity, which is 3, 2. And we have the time, 4 seconds, but we want to work out what A is. So this is going to be plus 4A. So we don't know what A is just yet. So to work out A, I need to isolate the 4A here. So I'm going to subtract these column vectors here. So in that case, I get 4A is equal to 15 minus 4 minus 3, 2. So 15 minus 3, that gives us 12 there, and minus 4 minus 2 is minus 6. So to get A then, all I do is I divide 4A by 4, and I'm going to divide this column vector here, each element by 4. So 12 divided by 4, that's going to give us 3. And then minus 6 divided by 4, that's just minus 3 over 2. Now just be very, very careful. This is technically incorrect because the actual answer is wanted in terms of I and j. So in that case, I need to write my answer in terms of I and j. So that's going to be 3I minus 1.5j. Okay. And because this is acceleration, again, don't forget your units at the very end. So that's part A done. Part B then, so again, I'm going to have to clear it all. So we want to work at the magnitude of F. So again, we're looking for the force here, so I'm going to use Newton's second law again, F equals ma. So F is equal to the mass, which we're told in the question is 2 kilograms, so that's 2, times the acceleration, which we've just worked out, so that's 3I minus 1.5j. So if you multiply 3 by 2, you get 6. If you multiply minus 1.5 by 2, you get minus 3. Okay, so it's 6I minus 3j newtons. So now, to work out the magnitude of F, we just take the square root of both, we square both of these and take the square root of the sum. So, if we do that, 6 squared plus minus 3 all squared. So what's that going to give us? That's going to be 36 there. This will give us 9. So 36 plus 9 is 45. This is root 45. And we can simplify this. This would be root 9, root 5, and then 3 root 5. Okay. So this would be 3 root 5 newtons, or if we give it as a decimal as well, that would be 6.71 newtons there. Okay, so that's part B done. And then finally for part C then, well, we're looking at the velocity of P at time t equals 6 seconds. So in that case, when t is 6, again, I'm just essentially using my SUVAT equations. If I write out, this would be the velocity at time t equals 6. That's going to be equal to my initial velocity, v at 0, plus the time t times the acceleration. Okay, so it's going to look like that. But again, this would just be v equals u plus at. So if we work that out, that's going to be v equals my initial velocity, which is 3I plus 2j, plus the time, which is 6 seconds, so 6 times A, my acceleration, 3I minus 1.5j there. Okay, if we work this out, so just plug all this into your calculator, 3 plus 18, so that gives me 21I, and then 2 plus 6 times minus 1.5, that'll give us minus 7j there. Okay, and again, this is velocity, so don't forget your units, it's per second there. Okay, and that's it. So that's that question done there, and that actually brings us to the end of this video. Hope you find this video helpful, and if there's anything unclear, again, just be sure to leave a comment down below. Cheers.